Welcome to the webinar, BMPs for Water Conservation. I want to begin today by presenting an overview. First, I'll talk about some of the benefits of using the information presented today. Then, I will talk about best management practices that refer to irrigation design, irrigation delivery, and decisions regarding irrigation management. Each of these categories, design, delivery, and decision, I will present a few BMPs, and they will be denoted by the blunt arrow that you see at the bottom of the screen. First, benefits of using the information. Certainly, we should be able to achieve some cost savings from implementing best management practices, particularly in terms of water conservation in the nursery or greenhouse. Should be able to reduce pumping cost, which this would ultimately then directly affect the bottom line, perhaps with increased profits. Plant quality would be another benefit from using the information presented today. Perhaps you would be able to reduce the numbers of cull plants or the plants that are not sold out of a given production batch. And environmental impact could be another benefit of using today's information. For example, if you are using best management practices, applying the appropriate amount of water, you should be able to manage runoff effectively, perhaps even reduce runoff to some degree. And if you're reducing runoff, chances are you're reducing the nutrient loading to waters that are adjacent to the nursery. Another benefit would be usually when you are using best management practices, or often when you're using best management practices, you are in a better position to receive cost share funds. Now, cost share funds are usually available for infrastructure types items at the nursery or greenhouse operation, such as a nursery runoff collection area, as you see here in this particular photo. Quite often a government entity or an organization will share in the cost with the nursery or greenhouse operation in building or putting in different infrastructure types of items. So now let's look at the different categories that we're going to talk about today in terms of best management practices for water conservation. The first is design of the irrigation system. Think primarily about the conveyance of that water from the water source to the point of application. What size piping system is required, how much piping system is required, what are the lengths of those pipes that are required. So we've got to make sure that we design appropriately so that we're delivering water effectively and efficiently at the application end of the conveyance system. Another area that we want to think about today is delivery of water in terms of water conservation. How is that water actually applied? And for example, is it applied uniformly? And the third category we'll talk about in terms of water conservation would be decisions, those management decisions that we make that affect water conservation. So in the category of design, we have our first best management practice. Design the irrigation system based on plant water use. Well, what exactly does that mean? It could be design the irrigation system based on plant water need. In other words, a mature, marketable size plant requires so much water each day to replenish its evapotranspiration. Let's, for example, take a look at Buddleia. I have plants two sizes here. The bottom row, the plants are larger. You can see the heights and the widths here. And in the top row, you can see the plants are smaller. You'll notice that the smaller plants on June the 21st, and these are plants in a number 3 container, that's about a 10,000 milliliter container. The plants, on June 21st, the smaller plants, 0.22 inches was required, or 0.22 inches of water was lost in evapotranspiration that day, and that would equate to 340 milliliters. Now you can see that a larger plant, a larger Buddleia plant, 0.38 inches of water was lost that day, or that was the evapotranspiration. That's equivalent to 590 milliliters of water. So now, considering, or if we consider that the larger Buddleia plant was marketable, then our irrigation system would have to be designed to supply at least 590 milliliters of water into that container, or 0.38 inches delivered from a sprinkler irrigation system over the surface of those plants. Now, but we've also got to remember that our irrigation delivery system is likely not 100% efficient. So really we're going to have to apply more water than, say, the 590 milliliters or the 3.38 inches in order to get the appropriate amount of water into the container. But the point here is that if you know how much water your mature, marketable size plants are requiring on a daily basis and you're going to irrigate daily, then you have to design an irrigation system to deliver or to meet that need from those plants. Now, usually we apply water in a given unit of time, a given period of time. For example, we make an application for 30 minutes, or we make an application for an hour, for example. And I mentioned the term area, or area basis, and what this means is that with an overhead sprinkler irrigation system, you're applying water uniformly over this area, so that if there is not a plant in the container here, for example, the water that you're applying over the area, all of that water has the opportunity that falls over the container to go into that container. Of course, you've got water out here that's falling between the containers. So from a sprinkler irrigation system then, you've got an application of water along this plane, if you will, or along this area of which water is falling at all locations. Now, if you look at the amount of water applied per unit of time on a container basis, what we are referring to would be just the amount of water that gets into the container. And this might be something that you would think about in terms of a micro irrigation system where you have an individual emitter in each container. So on a container basis, we've got water going in to each individual container, and this would be where we would deliver, for the example, 590 milliliters going directly into that container. We do not have, or we're not accounting for water that's applied, or water is not falling out here, because all of the water is being directed into this container when we're referring to a container basis. Now, we want to design that system appropriately to meet that plant demand for that marketable size, for that large size plant. But we've also got to consider the nozzles and orifices, for example, out in the production area, operate at a specified pressure that the manufacturer provides. So we've got to deliver the water to those nozzles and orifices at the specified pressure. So we design appropriately, we have the appropriate pressure, we have the appropriate amount of water to meet the plant demand at the production area. Now, the second category of best management practice we're talking about for water conservation is delivery. And the first best management practice is to apply water uniformly. Well, that seems like a pretty simple statement, but let's take a look in a little bit more detail at exactly what that means. Apply water uniformly from an overhead sprinkler system. That means that each cup gets the same amount of water. So you're applying overhead distributing the water overhead. Each cup then is supposed to get the same amount of water. In a micro irrigation system, water would be delivered to each individual container, and each container should get the same amount of water. So it's very, very important in the design of the system, the irrigation system, be designed so that this water would be distributed uniformly over the surface, and here that each emitter would apply the same amount of water. And one of the references or citations that I have at the end of the presentation will have a website where you can go and find detailed information about how to determine and calculate uniformity of application for both overhead and micro irrigation systems. Now, if we apply the water uniformly over the surface of these plants, we need to consider also that plant size and spacing can impact that water from that sprinkler irrigation system that actually goes into the containers. So when we apply the water overhead, we're going to be applying water in between the containers as well as over the surface of the plants. Well, obviously if you have a lot of open space, you're going to lose a lot of the water that you applied to runoff because there are just not as many units per area, as many containers per area on a wide open space as there are when you have the containers fairly close together. But let's think about a little more detail here. For example, you'll notice that the plant canopy here, or the foliage, the stems, etc., are outside of the rim of the container. So that we've got foliage outside the rim of the container. Now for many plant species, that foliage that is outside that rim of that container actually helps to funnel additional water into the container. Now what I mean by additional water would be water that would fall outside the rim of the container but yet falls on the surface of these leaves and stems and branches that are outside the rim of the container. So for many plants that we've evaluated, those outside branches and limbs and leaves in this particular area right outside the container does help bring some water from there into the container. So in a larger plant tends to be a little more effect in terms of bringing water in than certainly on a smaller plant. So if we move these plants together, for example, put them very close near each other, the plant canopies overlap, if you will. The leaves become mashed together. The leaves overlap. And that, in many instances, actually tends to decrease the function of those leaves in terms of bringing additional water into the container. Now, often in the nursery and greenhouse, we will talk about not putting the plants very, very close together because it decreases the quality of the plant. And often what will happen when we put the plants very close together is that some of the lower leaves in particular will turn yellow, and those leaves are turning yellow in response to the reduction in light because those lower leaves are being shaded by leaves above them, and hence then the quality of the plants are reduced. The next best management practice in the delivery category would be to use then the smallest optimal distance between plants in the sprinkler irrigated areas. So just as I mentioned earlier, we've got plant canopy that's outside the rim of the canopy, outside the rim of the container, that tends to bring additional water into or funnel that water into the container. So what we want to do is to have those plant canopies as close together as we can so that we can still bring that additional water into the container, but yet those containers or that foliage is not crowded, if you will, or leaves are overlapping to the extent that plant quality is decreased. And usually that closeness, or that smallest optimal distance, is at a point where the canopies are just beginning, the leaves are just beginning to touch each other. So the best management practice then is to use the smallest optimal distance between plants in sprinkler or overhead irrigated areas. Now, I mentioned about water getting into the container and how much water actually gets in the container. We can measure that and we often measure that by using a balance, something similar to a bathroom scale, and we weigh the plant. And we can do that because 1 gram of weight is equal to 1 milliliters of water. So for this particular plant, we would weigh for example, we could weigh the plant before we irrigate. We place the plant in this bucket or pail, and we put this foil around here, around the lip of the container and on the outside of the bucket, to prevent water from going, overhead irrigation water from going between the rim of the container and the rim of the pail, so that all of the water that comes over the top of the plant then goes into the container substrate. Now, some of it may go also down and be collected in the pail. So we weigh the plant initially, and then we irrigate the plant. Now, the increase in weight of the plant plus the water in the bucket then is the total amount of water that entered the container. So all of the water that entered the container then either increased the weight of the plant, or that water in terms of leachate is now in the bucket. So the sum of those, the weight of the plant, the water in the bucket, is the total amount of water that entered the container. Again, 1 gram is equal to 1 meal. So we weigh that again, and we can calculate then the actual amount of water that entered the container. Now, I mentioned that some of the water may not have been retained by the substrate. Some of the water may have leached, and so we could actually take and measure this leachate volume, or we could weigh that and determine the amount of leachate that we had. Now, one of our best management practices is to achieve a leaching fraction of 10 to 15%. Well, what is a leaching fraction? Well, a leaching fraction then is that amount of water in the bucket, that's the leachate that's in the bucket, divided by the water that entered the container. Now remember, the water that entered the container is the total amount of water. So the leaching fraction then is the water in the bucket divided by the water that entered the container. And the best management practice was that that should be 10 to 15%. Another BMP for water conservation that's in the what I've called the decision area, or decision category, if you will, involves collect and reuse runoff water. So in the nursery or greenhouse, the best management practice is to collect and reuse runoff water. In order to collect and reuse runoff water, this may require some management decisions, such as schedule irrigation to minimize leaching and runoff so that we do not exceed the capacity then that we have for our collection reservoir. We may have to make a management decision about when to irrigate. Perhaps if we had a cloudy day yesterday, we would not need to apply additional water today to some crops. Or we may just have to adjust, minimize or lower or make less the amount of water that we actually apply today because we had a cloudy day yesterday, lower evapotranspiration rates from the plants, so consequently today the plants did not lose as much water yesterday, or did not lose a large quantity of water yesterday, so we don't need to apply a large quantity of water today. So in summary, we first mentioned design irrigation system based on plant water use. In other words, if you've got a marketable size plant, it would be a large plant, we want to design the irrigation system so that we can meet the needs of those plants. So if you know the water use of the individual plant, when it's a large plant, you've got so many of those per acre, then you can multiply that up and figure out then how much delivery or how much water you're going to have to meet the needs of those crops for a given amount of irrigation time then. So for example, if you know that you can deliver that amount of water in 30 minutes or an hour, then you have to design an irrigation system to meet those specifications. Apply water uniformly. Mentioned about overhead application in the cups. We wanted to have that water uniform across those cups. Or on a micro irrigation system, we apply the same amount of water to each container. Use the smallest optimal distance between plants in sprinkler irrigated areas. I mentioned to maintain plant spacing so that the canopies of those plants are just touching each other in order to achieve the maximum use of the irrigation water. Achieve a leaching fraction of 10 to 15%. This is where we talked about the amount of water that actually got into the container, the amount of water that leached through. So we took the amount of leachate, or the amount of water in the bucket, and divided that by the total amount of water that went into the container. Collect and reuse runoff water. This involves some decisions, some management decisions, so that we will irrigate as needed, when needed, so that we do not exceed the capacity of our collection systems and reservoirs. In conclusion, I provided some references. The first is a website at the University of Florida, and where you can find information on uniformity both for sprinkler irrigation and micro irrigation systems, as well as you can find additional information at this website for other aspects of container plant production. The second reference is the Ohio Florist Association Bulletin number 930, which I had a recent article on water conservation, and I go into many different aspects of water conservation, and certainly in more detail than I've covered in this particular webinar. The last would be Best Management Practices Guides. The first is the Southern Nursery Association web address, and at their website they have an order form for the Best Management Practice Guide from the Southern Nursery Association. And the last web address would be for the Florida Department of Agriculture Office of Water Policy, where you can go and print off the container BMP Best Management Practice Manual for the state of Florida. Thank you for your participation.